All right, our next lesson in statistics is going to take a look at standard deviation. So when we look at standard deviation or the measurement of dispersion, consider the assignment question from the previous lesson comparing the average daily temperatures in Nanaimo and Toronto. So in this case, we have it listed out as a table. Here are all the temperatures for Nanaimo, here's all the temperatures for Toronto. And we can see that all of the data has been listed out. Here's Nanaimo, where it's in black, going through here with all the points. And here's Toronto listed in white. There's the points where they match up. And then it comes back down. We can see that when we add up all of them and divide by the number of terms we have, the average or mean temperature for both of them is 9.5. The median, or the number that is right in the middle, is going to be 9 for both of them. Now, the measures of Toronto are more spread out or more dispersed than the average measures in Nanaimo, using only central tendency, so the mean, median, and mode that we were using in the last case, to describe the data does not reflect the differences in the temperature between the two cities. Obviously, just from looking at it, we can see that Nanaimo stays much closer in temperature and Toronto is far more spread out. So, if we include a measure of dispersion together with measure of central tendency to describe the data, we can get a clear understanding of the similarities and the differences between the average daily temperatures in the two cities. We have met one measure of dispersion in previous courses that we call range. What is the lowest to the highest, or how spread out are the values that show up for y? So in this case, if we're talking about the range of temperatures in Nanaimo, well, going from the lowest temperature that it has to the highest temperature that it has, it goes from 3 up to 18, or has a range of 15 degrees. For Toronto, it goes as low as -4, but as high as 23. This one has a range of 27 degrees. One disadvantage to using range as a measure of dispersion about the mean is that it only uses 2 of the data values and can be influenced by one extreme value. A better measure would be a measure which uses all the data values in its calculation, such as standard deviation. So this would be like saying, if I was looking at the marks spread out on a test, well, if I found that the average for the test was like a 60%, but most people were in the 50s, and then one person got like a 95% on that test, then it would have a big spread of about 45 degrees, or 45 marks, but at the same rate, we would know that most people, that wasn't the case. It's the same as if I had one really low mark. So if I only look at how spread out the marks are, then it looks like, oh, there's much more variety in the marks than there actually is. Really, it's just one outlier. So that's where we use our standard deviation. When we talk about standard deviation, it's the measure that describes the variation or spread between the data values and the mean data. That's a fancy way of saying how far away from that central average data does it get. A low standard deviation means most of the data values are very close to the mean. Hence, the data values are more consistent. A high standard deviation means most of the data values are scattered further away from the mean. Hence, the data values are less consistent. Standard deviation is often used to compare two different sets of data. The standard deviation of a population is denoted by the symbol of sigma, which is that fancy-shaped O. In this course, we will assume that all data comes from populations and we'll use them for the symbols mu, for mean and sigma for standard deviation. And once again, on your formula sheets in the back of your book, these are the symbols that you'll see, mu and sigma. The population standard deviation, or sigma, can be calculated saying that sigma is going to equal the sum of x, so my piece of data that I'm deciding, minus the average data squared divided by the number of data pieces. For each data value, calculate the deviation or difference from the mean, square each of the deviations from the mean, add up all the values in 2, and then divide the answer in 3 by the number of value datas, and then take the square root of that answer in order to solve it. So this looks more complicated than what it actually is. Let's take a look at how this works in practice. So first, I'm going to calculate the average height in these cases. I'm going to say that mu is going to equal 170 plus 182 plus 193 plus 193 plus 212 divided by the 5 pieces of data that we have. U equals 190. Now, I'm going to take all these pieces of data and say, what is the deviation from the mean? So if I take 170 minus 190, I get negative 20. When I take negative 20 and square it, I get 400. 182 minus 190 is going to give me negative 8. When I square that, I get 64. 193, take away 190 is going to be 3, and I square it and get 9, and that's going to be the same for this one. And 212 minus 190 is going to give me 22. When I square that, I get 484. When I add up all the numbers on the left, then the deviation from the mean is going to average out to 0. Because if I take above and below and add up all those differences, it should give me 0. It should balance out to what the mean is. When I take the deviation squared, I get 966. So that is how much spread there is. I can say that sigma is equal to the square root of 966 divided by, I have 5 pieces of data, or sigma is equal to the square root of 193.2. Sigma is going to equal 13.9. So this has a standard deviation of 13.9 centimeters. Now, it's important to note you are not, for the test, going to have to calculate the standard deviation manually like this. It is a requirement that you can use the stats feature on a graphing calculator to do this. Remember, if you do not have a graphing calculator, you're going to need to either do it using this method, or you're going to have to pull up, and obviously you won't be able to do this when you do it in your course next year, but you're going to have to pull up like an app or something like that, like a graphing calculator app or a stats app, in order to be able to calculate this stuff.